we were just talking about this last night. This question of how to define intelligence. And this seems to strike at that somewhat, which is that we came up with the ability to innovate, to conceptualize things that are related to each other but that have never yet before been related to one another, and then be able to apply them. And we were talking about it in context of, because we do these short films, and so we were thinking about, well, we should do one about whether or not
is artificial intelligence intelligent?
yeah, exactly. And so this seems to be suggesting that when you network things together that are able to make these network style connections, that you are suggesting that it does become intelligent.
Well, intelligence is also a tricky topic, but it's not as bad as the other one. So I'll deal with that one a little bit.
I was trying not to say the C word, so I'm glad that you rescued me.
Yes. So one way to think about how smart is a learning system is the quality of the generalization that it can do. So if it's not doing any generalization, it's just doing rote learning, right? It's like, this is good, do more of that. This is good, do more of that.
So it's like teapot, but we'll never get to container.
Okay, yes. Yeah, I wasn't expecting teapots, but yes, I get the idea. So, if a learning system generalizes well, then it can take specific instances from the examples that it's seen in the past and apply generalized knowledge to a situation that it hasn't seen before, but get the right answer, right? So this is kind of the opposite of deduction. In deduction, you go from a general rule and it enables you to infer specific conclusions which are accurate. Like, well, the classic is that all men are mortal, Socrates is a man, so Socrates is mortal, right? And that conclusion follows deductively from the general rule to the specific example of Socrates. But induction goes the other way. Induction says, this swan is white, this swan is white, this swan is white. All swans are white, right? So you have specific instances, and then you have a general rule. All swans are white, right? So this is a swan, it must be white. But you'll notice something wrong with inductive reasoning already, because not all swans are white. Right. So induction doesn't follow logically from the samples that you've seen. And that makes sense because you're trying to build a general rule from specific examples. And the specific examples can't really support a general conclusion. All you really know is that those three swans you saw, all the swans you've seen so far were white. Right. It doesn't really extrapolate into the future or to other instances. So induction seems like the sort of poor cousin of deduction. Deduction is logically sound and induction is not. But induction is absolutely vital to learning, right? The ability to generalize, the ability to take experiences from the past and apply them to a new situation, or to apply them in a new way to the same situation. That kind of generalization is absolutely essential to learning, because otherwise you're just doing memory, you're just doing memorization, you're not doing learning, right? So the ability to do induction is fundamental to doing generalization, and generalization is what we really mean by learning. Right? If you're doing learning without generalization, that's just memorizing stuff. And that's pretty, I'm not going to say it's the definition, but it's pretty central to what we mean by a system that's intelligent, right? When your tutor is trying to get you to learn the material for the exam, if you just memorize it, that's not intelligence. But if you understand it well enough, what does that mean? It means not only can I do the examples which you gave me in the homework and you taught me in class, but I can do other examples I haven't seen before, right? That I can take that experience and apply it in a slightly different situation to see what's common between the things I have seen in this new situation that I haven't seen before, right? That ability to transfer past experience to new situations, like I say, it's not the definition, but it's pretty core to what we mean by a system behaving intelligently.
Mm-hmm.
And that's exactly what natural selection doesn't do, right? Natural selection, the classic way to explain how did this good solution to this environmental problem arise? It's like, well, because when that solution arose by chance, it survived and reproduced better than the others. That's just deduction. It's a specific instance I've already seen. Right? This thing survived and reproduced in this environment. That can't be wrong.
It's always struck me as that ideas are often polluted by a reaction to what came before them. And I think that with Darwinian evolution, there was this great resistance to the idea that there could be some sort of action on the part of the organism to influence the traits. And I think that this has to do with the Lamarckian thing of, the blacksmith has big arms because the blacksmith blacksmiths. And everybody, once Darwin came up with this theory, everyone viewed it as very quaint and sort of, how silly they were. But you come to the modern world and people are slowly starting to come up with epigenetics, and there's all these mechanisms by which it does appear that mental states of some kind are transmitted generationally. And so if that is the case...
Like the immigrant mindset.
Yeah. It's like, I think about this all the time. I immigrated with my parents from Russia when I was a kid, and I don't look different. But there is this difference in mindset where I'm like, well, there's something that stretches back into time that is apparent in me that's not apparent in others. And so it seems that there was a push against this for a long time because people didn't really want to consider that there was something motivating, some will, some intelligence that transfers from generation to generation. And it seems like...
when you're talking about organisms that do have intelligence and do have will, then that's okay, right? As though somehow something that humans do and perhaps some other higher primates, as though that's unnatural in some way and therefore special. But everything else in the universe doesn't work like that, right? It doesn't have will, it doesn't have intentions, it doesn't I said I wasn't going to talk about belief, desires, and intentions, but
you can't talk about biology without talking about it.
Yeah.
Well, yeah, people seem to think, biology is only half physics, right? There's all these other software level of things going on, and they're very difficult to talk about without bringing in these metaphysical words like intention and...
Well, they're very, very dirty words in biology. You can't use words like that.
I'm not
right?
sure that's reasonable, though.
I remember.
So the key thing about why is natural selection the only process that can explain biological adaptation is about whether the variation is directed, right?
And that's the core of it, right? Because it feels like it has to be on some level.
The Lamarckian view that they changed in the direction that they needed to change because that was the need. That's the thing that natural selection threw out, right? And it's not just that the an absence of a mechanism that could explain the inheritance of acquired characteristics, right? That's not the reason that Lamarckianism was thrown out, because although we didn't have one at the time of Lamarck, we have them now, but it doesn't make, an adaptive process Lamarckian just because you can epigenetically inherit characteristics from your parents. And it doesn't mean that you have a different process of adaptation just because you can inherit a mindset or a cultural difference from your parents either, or pass on a meme to another person in the population. The point is that, yes, things change over time and they can be inherited over time, but why should they change in the direction that makes them better instead of the direction that makes them worse? So if the individuals that are doing the passing on are modifying them as they go in a way that makes them better, well, fine, right? If they're using their individual intellect to modify them in a direction that provides an improvement, then yes, you can have directional change. But in the absence of such a process, the only other way in which anything could get better instead of just change over time is through selection. So the orthodox view goes, right? So Dawkins has made the case very strongly that it's not just a matter of fact that it happens to be the case here on Earth that natural selection is the mechanism that explains all the adaptive biological complexity we see, but that it couldn't work any other way, because any other way in which it could work would require directed variation, right? It can't. How would it know to change this way rather than change that way? It can't can't know that. That would require some foreknowledge of what was needed. So it has to change in a random direction. Well, now that's no good. We don't want things changing in a random direction. So we introduce selection to give us directionality in the trajectory of how things change, without assuming directionality in the way that things varied originally. So they can vary randomly, but you keep the things which are good, right?
Well, there is also a reluctance to say that evolution is a history of progress, too, right? Where, you know, the centralists. And so my background
the
is
P word.
Yeah.
There's also plenty of stuff that's not evolving necessarily, right? I mean,
you mean like rocks?
Oh, it's just like there's still bacteria that many scientists claim are essentially undifferentiated from their original form.
Bacteria are weird because the bacterial genome, when you start trying to reconstruct phylogenetic trees, just kind of turns into like bacterial soup at the bottom, where everybody's trading genes back and forth. And so it's very hard to do phylogenetics back to like a universal common ancestor.
They're not, growing arms and stuff.
So that I think partially has to do with the fact that we have really bad surveillance techniques. Like I think about this all the time, where if life was evolving kind of de novo on Earth right now from inanimate stuff, you wouldn't expect to be able to see it. And so that's a surveillance problem, right? And I think about viruses all the time, where I'm like, well, viruses...
Because it wouldn't get to high enough frequency before something ate it anyway, right?
Exactly. Or it would
you
take
just assumed you'd found a new level, a new species that you hadn't seen before.
I mean, yeah, bacteria, you have a genome that appears and it's an unrelated genome, and you're like, oh, look, it's a new bacteria.
And convergence is very difficult to tell apart from
But this is, we're spiraling at this point. Back to the idea of evolution and better, where I struggle with this because I studied microbiology, and at some point I was looking at bacterial colonies, and I really got this feeling where they were these megalopolises. I always thought about them in context of Kowloon Walled City, which was this very, very dense enclosure in Hong Kong that they tore down in the 80s. But it was the densest city on Earth for a long time. And so I viewed bacterial colonies as very, very similar to Kowloon Walled City, because it was this complex engineering and social problem, and there was all of these different classes of bacteria, and they were doing different things, and they were producing different goods. And obviously it's not a civilization the way that we see it, but I always imagined that a bacteria inside that biofilm was definitely in a civilization. And so it's hard for me to be like, well, human civilization is better than bacterial civilization, because, I mean, obviously I prefer our civilization to biofilms, but is it really better?
Only because you're not a bacterium. You'd love it if you were a bacterium.
Right, exactly.
So the possibility that there's some system level organization going on in complex systems like that above the level of the individual is one of it's an idea which draws many, and it's an idea which is ruled out by the assumption that natural selection is the only process that can produce adaptive change. Right? So it could be the case. So many people have likened bacterial biofilms. You look at the different complexities and the diversification of roles and the different multiple species interacting with one another, and the progressive stages in which they build biofilms, which are sort of predictable, and the structures which are specialized in some sense to producing propagules which break off and start other biofilms somewhere else. And there are others which are just sort of soma, as it were. They're non-reproductive, or they don't make it in the long term. And the biofilm begins to look more like a functional unit at a high level of organization over and above the level of the individual bacterium, right? And, likewise, people make analogies with humans in cities, and they also make analogies with all the living things on the planet. Maybe that's like an organism too. Maybe that has functional organization that's greater than the sum of the parts, right? That there are the biodegraders and the other organisms which are in the trophic levels, which are creating nutrient recycling processes, which are regulating this and regulating that, and creating refugia that enables parts of the ecosystem to survive through forest fires, whatever story you want to make about sort of functional organization, the Wood Wide Web, functional organization happening at a level above the level of the individual, right? And the classical view, very nicely represented by Richard Dawkins, says, well, that can't be unless natural selection was operating at that scale. Maybe for bacterial biofilms, sometimes a bacterial community is an evolutionary unit. You have a population of biofilms, and some biofilms are better at surviving than others, and they're better, and whatever it was that made them different is transferred to offspring biofilms in the next generation of biofilms. And by the way, that needs to be more than the sum of the heritability of the bacteria they're in, right? It needs to be a characteristic of the diversity and functional organization of them, not just, well, this biofilm had a lot of this bacterium in it, so the next biofilm has a lot of that bacterium in it, right? So maybe at that sort of scale, there could be sometimes, and maybe at larger ecological processes, when you think about rafts in the ocean that have a whole sort of system of biota around them, maybe there's some sort of community property that makes one raft of biomaterial more successful at surviving than another, and maybe that could inoculate another raft with the right kind of species combination, and that would provide a sort of group level selection.
The trick is you need populations to compete with one another, right? Like that's the essential part of the Darwinian model.
Yeah.
You have to have these cultures at war with each other, essentially.
That's right. You have to have a population of them, and they have to be competing for survival and reproduction in order for you to have adaptation that belongs to the system level. And the conventional view is that that can't happen except in very special circumstances where there's some sort of container or some sort of way that creates some sort of heritability at the system level that's over and above the heritability of the parts, right?
Do countries and ant colonies and things like this qualify?
Forests.
Well, right. So, those things are not all the same, right? So ant colonies might, but the classical view is that they do because, well, they all have homogeneous genetics, right? So we can explain this as the selfish interests of the genes involved, transmitted through multiple generations, and the colony is just a sort of extended phenotype of that genetic lineage.
So there's no mimetic no mimetic quality that's being inherited from generation to generation.
Well, there might be, but what would be the mechanism that made that directional? Right. So if the only mechanism in the universe that can create improvement is natural selection, you have to find a way in which natural selection is involved in order to explain any of these other processes as being an explanation for the adaptation that you see. And, countries, well, they can't be evolutionary units unless countries have properties that are holistic, that differentiate them from other countries, that enable them to survive better than others, and they reproduce in a way that those characteristics can be passed to an offspring country in some way, right?
So you could kind of see it.
More likely, the individuals. It's a different way to explain it is that if you were talking about an ecosystem, right? You had an ecosystem that was particularly healthy and productive and had large biomass, therefore. There are more individuals leaving that ecosystem than there are ecosystems which have a less complementary combination of species. So they would be seeding more descendant ecosystems than the less successful ones. But it's hard to make that work when you have individual level selection that's working against it and is probably stronger, right? So if you're an individual within such a community, you benefit from the productivity of that community, and perhaps you contribute something to that community. But if there was a variant of you that benefited from the community but didn't contribute, well, I'm better off then, right? So a selfish individual which doesn't contribute to the public goods is always better off. Or all of your argument about why this community worked well is still true. but you have to also explain why it isn't undermined by individual level selection.
We did actually we did a film about this a while ago where we were looking at the way that biology tends to deal with cheaters, which is that technically, if it really is better for the individual to cheat, then you would expect all societies to be eventually overrun by cheaters and all communities to eventually collapse, because it's always better to not produce the good than it is to produce the good and have somebody take it. It's basically the maximum of game theory, where you would expect that everybody just wouldn't take on the burden, but that's not what you find in biology. You find I don't think so. I mean, I think that people say that about humans, and with humans, there's all of these systems. I think that corporations throw a weird software wrench into the plans that it makes it very difficult to be able to assess human behavior. So you have to look at animals that don't have corporate structures in order to be able to evaluate. And it seems like there's not a rampancy of cheaters that destroy the entire population. I just don't see that. Like, I don't see the squirrels or the ants or whoever else just collapsing because everybody's starting to cheat. Am I not seeing?
Yes, they do. Yes, they do. I'm just channeling Dawkins, right? So the conventional view is that whenever there is an opportunity to cheat, the cheater proliferates, because that's the definition of what it means to cheat, right? That you're gaining some benefit from the community without giving back. That cost benefit has got to be better for the individual than one that does give back. So that must be what happens in nature, unless there was some higher level selective process, right? So if you had a higher level selective process in place, so you had, groups that were reproducing with heritable characteristics that belong to the group, then maybe a heritable characteristic you'd have in that group would be mutual policing or something like that. And then a group which had mutual policing would be able to keep its cheaters under control, and a group that didn't have mutual policing wouldn't be able to keep its cheaters under control. So then we've invoked natural selection at a higher level of organization in order to explain why within the group it was cooperative.
So what's the inductive alternative to this?
You don't have to have a natural selection process in order for a network to get better at doing something over time, right? So when
so the self-policing would occur in the absence of competition with other cultures.
It's
in that analogy.
You can get a system of relationships of individuals that work well together, that although they are motivated by their self-interest, the relationships that they create causes the system as a whole to operate with greater harmony, basically, to resolve more conflicts among the individuals with experience. So,
this seems like
explain how that works?
Well, it seems like it would operate like the minute that you're out in the world, you then have to consider things in terms of competition, right? If you have two biofilms and you're talking about one biofilm cooperating and another biofilm not cooperating, then you kind of by necessity are talking about natural selection, because you're like, well, one will survive and the other one won't. But if you're talking within the biofilm, right, where you border the system, and you say there's dynamics that are happening here that are not necessarily shaped by competition. It seems like that is the realm of natural induction, where not everything has to be looked at through the lens of intergenerational competition with a group of others, or even with individuals within the group. Is that kind of where you're going?
So that story but within the group they were cooperating. So the dynamics that's going on within there is not all cutthroat, it's not all dog eat dog, it's not all for themselves. There's something more cooperative going on. So it's still true that if you could find a way to cheat within that system, to act like you were obeying the laws of the mutual policing society, but you actually weren't, you would still proliferate. And the only way in which the policing structures were there in the first place was because you invoked a higher level selective process where one with a good policing structure outcompeted one with a not so good policing structure. So that whole story still depends on natural selection for the cooperation to have arisen in the first place. And it still there's a sense in which the cooperation provided by the higher level competition is still fighting against the individual selfishness at the level of organization all the time. And that doesn't go away, right, under that story.
Mm-hmm.
The story about how natural induction might work is it's a bit more subtle, and you can still describe it in terms of selfishness at the individual level, but the selfishness at the individual level isn't where the creativity of the process comes from. Creativity of the process comes from the organization of the relationships that those self-motivated changes create. So if we were to imagine, I haven't tried the analogy this way before, but imagine that individual neurons were motivated to find connections that satisfied those simple associative learning rules that we were talking about in artificial neural networks before.
And these are just rules
correlation learning.
And these are rules that just feel good? Like, how does it, I think that that's important. I think that cells do feel good. I think that you have to have this idea that there's a state that they move towards that is not a state that is encoded by some hard thing, but it is a feeling thing. That feeling thing might be calcium concentration or whatever, or that's the mediator, but it moves there because it has will. I think that we have to accept that has to be in biology, because to treat biology as being absent of will is lunacy, and everyone does it. And I know
that's fighting talk.
I know it's lunacy.
But is it really that more far out than the idea that a group can exhibit creativity or something like that? I mean, it's almost like where there are these collective level processes that are inevitably occurring all around us, and I feel like people point at Darwin because they don't want it to be the case, because it'd be a lot simpler if there weren't collective level processes that we had to reckon with. Like, it reminds me of the classic Ayn Rand take on the universe, which is like, oh, just, take care of everything in your own little bubble, and if you just master that, everything will be fine for everybody. And the problem is it doesn't really work that way, because nobody exists in a vacuum. And I feel like this obsession with the Darwin perspective has to do with the fact of what we want to see rather than what might actually be happening.
Yeah. So I'm glad you bring up Rand. So it's a favorite foil, right? So that the virtues of selfishness, Rand's book, right? It's not just saying. So one way to think about, when we think about natural selection in terms of a phrase like survival of the fittest, right? That's taken as not just a way of explaining biological adaptation, but as a worldview, as an ethos of how we should behave as individuals, right? That's a natural, not just a natural way of being, but a good way of being. And so not just something that we should tolerate, that, well, that's tough because that's the way of the world. It is dog eat dog out there, just get on with it. But that it's actually virtuous, that if you were to interfere with that in any way, if you were to interfere with the competition, you'd be making it worse, because competition is how things get better. So it's good that everything's competing. It's good that it's dog eat dog. Selfishness is a virtue which enables the system to find an equilibrium where there's no inefficiency in it anymore. And that sort of mindset is not just something which pervades evolutionary biology, but it's something that pervades the way in which we think about ourselves and our relationships to one another and our relationships to the rest of the biosphere, right? That it's, might is right. If I can find some other way of consuming some other species, then go ahead and do it. Oh dear, they're all gone. Never mind. I'm still doing, I'm still behaving the way I was built to behave. Otherwise,
where'd all the fish go?
Yeah, where'd all the fish go? Where'd all the turtles go? Yeah. So that if there's I think that the thing that I'm excited about discovering another way in which complex systems can become adapted is that the way in which it works is by the differential easing of frustrated relationships in the network, not by I survived better than you did, or I reproduced, grew faster than you did, and outcompeted you in some sort of race, right?
It's like we both grew better because we solved this. Is that?
The way in which I satisfied what I wanted to do better was by changing my relationship with you so that we were less frustrated in the way that we did that, right? So if I want to do something, you want to do something else, and that doesn't create any frustration for me, then fine, leave that connection alone. But if I'm trying to do something and you're trying to do something else, and that makes life difficult for me, I need to change that relationship. And it's natural, whether we're talking about two masses connected by a spring, or two people in a social network, or two species in an ecosystem, or two bacteria in a biofilm, it's natural that the frustrated relationships are the ones you want to change the most, and the ones that are okay, you leave alone, right? And that differential changing of the relationships changes the organization of the network, and changes, therefore, the way in which they interact with one another and behave as a whole. And more specifically, it changes it in exactly the same way that a learning neural network changes its connections. So the simple rule that you use in an artificial neural network to cause the network to be a model of its past experience, including the possibility of generalization, is that when whatever the two neurons are doing right now, you change the connection in the way that makes them less frustrated about that, right? So if one neuron is trying to make another neuron excited at the same time, but it's not, that connection gets weaker. If two neurons are both excited at the same time, the connection gets stronger. Or if they're both depressed at the same time, the connection gets stronger, because that's okay too. But when they're doing different things, the connection changes with the opposite sign, so that it makes them more comfortable being different. But whichever way you look at it, the connection just changes in a way that reduces the frustration in the network. And ordinarily, we think of that as a learning mechanism. It's something clever that was designed for the purpose of making the network learn. For example, I'm describing Hebbian learning by Donald Hebb, right? That the way neurons that fire together, wire together, it's a learning mechanism which is clever for the purpose of making brains form memories and do generalization and stuff. But actually, it's a perfectly natural property of any network where connections give way under stress. And that means that it applies to networks that aren't evolutionary units, like social networks and ecological networks and the biosphere as a whole.
What are the civilization level repercussions of the work that you're doing? If we started to look at our intersocietal processes this way, are we talking world peace? What is obviously some of the benefits of this are obvious, but maybe you could just talk just for a moment about where you see this being applied to the problems in our world today.
So I am a big fan of Jeremy Lent. I don't know if you've come across his work. He wrote a book called The Patterning Instinct, and then The Harmonious Web of Life, his second work, more recent work. In it, he describes crudely Eastern versus Western worldviews, right? So Eastern worldviews, apologies to Eastern worldview holders, right? But I'm going to butcher it somewhat. That's an unfortunate turned phrase. It's basically, everything's connected. We're all part of a harmonious web of life. Love is the way. Let's just learn to get along. My vibration sets up resonances in the rest of the network, and the rest of the network modifies my vibration. It's all a harmonious web of life, right? And we're all playing a humble role within the harmonious web of life. Love is the way. And I'm saying it in that somewhat patronizing tone, because that whole view of the world, that worldview, is completely thrown out by the Western worldview. The Western worldview is based on survival of the fittest. Now, selfishness in human culture existed long before Darwin came up with the theory of evolution by natural selection, of course. So you could argue about whether survival of the fittest came from that worldview, or that worldview is supported by survival of the fittest. But they are nonetheless congruent with the Western worldview that selfishness is right, might is right, whoever's the most powerful is justified in doing whatever they can do with that power. Growth is the way in which everything improves. If I grow faster than you and that outcompetes you and takes away your resources, that's all great. anyone else and everything else is a commodity just to be exploited and consumed.
But those aren't really at the core of Western
right?
spirituality, right? I mean, if you look at Christianity, which is arguably the most popular religion on the planet, certainly the Western popular religion, it's rooted in the idea of loving your neighbors and the golden rule and all of this. And honestly, if you look at this sort of Machiavellian picture you're painting, you find it in the East just as much. As I'm thinking of all the way back to Genghis Khan and the
No.
rape of Nanking and there's all sorts of terrible selfish behavior in the East as much as in the West. And the spiritualities really do converge. They're of course corrupted, but they do converge on this idea that we should be taking care of one another. And so I understand you're summarizing this gentleman's perspective.
But that's a particular dominant kind of Western spirituality, rather than what I was trying to describe as a Western worldview, right? So that spirituality is conjured up as a ethos by which we should rise above what's natural, right? The natural way of the world is selfishness and short-centered, and short-sighted and self-centered. But in order to combat that, we special humans should somehow rise above that and do something different. Right?
Well, I think
by sheer virtue of our will.
I think that there is actually a great division here, but it lies, the way that I see it, along the divisions of spirituality versus dominance or power, right? Because the spiritual perspective is one which seeks to understand this resonant connection between forms.
Yeah.
And then there's the other form, which is the power-seeking form, which is the form that seeks to dominate and to say, no, I will not be informed by the vibration. I will set the vibration. And
some religion, the R word. So
we're getting deep here.
Some religion is, of that spiritual form that, playing a humble role within the greater whole, right? But some forms of spirituality, some religious forms of spirituality, are more about, we're special, we're in control, God made us this way, the rest of the dominion is only there to serve us. And that attitude towards the rest of living things, we're the pinnacle of it, and the rest of it is just a commodity for us to use, given there for our good graces, is an attitudinal thing, which is still an attitude of privilege towards the rest of the living world, right? But anyway, I shouldn't get too embroiled in.
Well, no, I think it's relevant.
The social history of East versus West and the role of religion therein. But what I can contribute to it is that Western's reductionist science way of treating those connected, harmonious web of life is that's all mumbo jumbo, because life isn't an evolutionary unit, and so it can't be organized, let alone harmonious in any way. It's just a jungle out there, right? It's dog eat dog, it's each for himself, right? So you might have an ideal that you should treat it differently, but the reality is that that's the way nature works, and it has to work that way because there isn't any other way that it can work, because natural selection is the only mechanism that changes anything.
But you don't think so?
Well, I don't think so. So if, the biosphere as a whole, right? So let's take that level, right? The biosphere as a whole.
Before we go on, I just want to make one comment. It seems like religion is actually the concretization of that collective spirit, that collective body that you say the collective could be creative, whatever that even for the body. It's not really a body, but it's a collection of individuals. And it's almost like religion is trying to capture that, write it down, make these inductive laws almost. They're like, this is the case. Like, if I kill my neighbor, it's not going to work out for me, so I'm going to make a law about it. And then that collection of laws becomes this binding religion, essentially.
Well, maybe, but the universal Darwinism way of explaining that is that one religion competes against another religion. and a society that's controlled by religion X does better at surviving and reproducing, growing than a society dominated by religion Y, right? And it's still competition at a higher level of organization that sorted out why that religion works that way, or whatever that kind of cultural institution is, whether it's religious or a system of laws or a system of government or whatever it is that you're doing. It's all competition that drives it into an organization that works well.
But do you think
because
there's
competition is the only mechanism?
Right. So what else is happening to do it? What's going on?
So let's take the story of, can the biosphere be adapted, right? So the Gaia theory of looking at the biosphere, that the observation is that there are many complex feedbacks between many different kinds of species and many different environmental variables, and they produce homeostatic regulated control of many variables like temperature and light reflectivity, which is important for maintaining conditions that are appropriate for the perpetuation of life on the planet. Well, that all seems very clever. It's almost like it's an organism that's regulating its own internal variables or metabolism. The planet is like a giant organism. Oh, no, it isn't, says Richard Dawkins. The planet can't be like a giant organism because organisms are adapted to produce holistic function by natural selection, because there's a population of organisms through differential survival and reproduction. But the planet isn't an organism. More to the point, it isn't an evolutionary unit. There isn't a population of planets, and there isn't a planet that we know getting daughter planets, right? Well, that has any interaction that we can see with ours, at least. So if you were to try and support the claim that the biosphere as a whole is organism-like in the sense that it's adapted for holistic functions, well, it just can't be unless natural selection was operating at the planetary scale, and you can't have natural selection in a population of one. Right?
He wasn't a big UFO buff, Dawkins. So what do you think is happening? Yeah.
Okay, so let's think about what the effect of natural selection on individual species is to the organization of the relationships between the species in the biosphere as a whole, right? So it's clear that individual species, or individuals within each species, in fact, are subject to differential survival and reproduction, so they can be adapted by natural selection. But what is the holistic effect of many species, each evolving in competition with each other, right? What does that do to the organization of the network as a whole? Maybe the most selfish individual would just take over and that would be the end of it, and then we've destroyed all the resources and that's the end of the story, right? That is one possibility.
Many have tried.
But yeah, we're trying to understand what's the relationship between the adaptation of the individual parts and the organization of the whole, the adaptive organization of the whole. What's that relationship, right? And the work in neural network models shows us that you don't have to have a population process or even any system level feedback in order to get a network that can learn, adapt, and get better at problem solving, get better at optimizing over time. Because you can do it all with completely decentralized updates to the connections. All you need to do is have the connections differentially relieve the stressed relationships. So you need some other conditions, like there needs to be some sort of episodic stress, right? If the conditions were perfectly stable, then the connections in the network would change over time, but not in a way that learned anything, not in a way that built a model of what was going on. But if the system is perturbed, it's shocked and relaxed, or there's a variable environment that's it's stressed this way, and then it's stressed that way, and then it's stressed the other way, then that gives in each of those stresses or each of those experiences, the connections of the network change a little bit, and they change in a way that just accommodates what's going on. They just, I was a bit frustrated by that. Let's just change the connection so I'm less frustrated by that, just relaxing into that shape, as it were. But over many such experiences, the connections in the network change in a way which form a generalized model of those specific instances. So instead of just memorizing one thing, you get an induction of a network architecture that represents not just those experiences, but others. It's a generalized model of the past experience that's happened at the system level.
And this can all be happening at the same time as competitive processes. This is just a parallel.
Yeah, so the
circuit.
competitive processes can be happening at the micro scale, as it were, at the between individuals within a species, for example. But the ecological network, the community network, can then be exhibiting natural induction at the system scale. So my student worked this out, or did a model of this for an ecosystem of individuals within multiple different species, where the assumption is that all of the individuals within a species are competing with one another to grow the fastest. And all of the species are competing with one another for the resources that are available for them to grow with. But under these conditions of a sort of episodic stress, the way in which one of the ways in which an individual in this species can get ahead with respect to the other individuals in that species is by having slightly different relationships with the other species. Namely, if it changes its relationships with the other species in a way that eases the relationships which are frustrated and amplifies the relationships which are not, that makes it grow faster. But the effect of everybody in all of the species doing that simultaneously is that the network as a whole is learning like a neural network learns. And he used that to, sorry.
I was going to say, how do you measure tension in a because I can imagine tension in an ecosystem being survival, right? So, and you have the tension is I have to compete in order to survive, but if I can change my behavior in such a way that I am not competing with this other species, then I have eased this tension for myself.
Yeah, so I guess I'm using it in a way that's specifically about relationships, right? It has to be about an interaction between two things, not just a stress that's on me, right? So, it's too hot, I need to have a more reflective skin color or something, right? That's just about me. And that might make me survive and reproduce better than other individuals in my species, but it doesn't change the relationships that I have with the other things which are evolving.
I'm thinking more where it's less I need to change my feather color, and more we eat at the same time and we don't get along, or we eat the same thing and we don't get along. That sort of shift.
So if we imagine that one species uses resources that may or may not be used by another species, and if two species use the same resource, then they might be in competition with one another for that resource. But if this species is in high density at a time when I'm not in high density, then actually they won't be consuming the same resources that I am. Or if I'm in high density when they're not in high density, I won't be consuming the same resources that I am. The frustration arises when we're both in high density at the same time, right? And then our competition for the resources is frustrating, right? That's what I mean by there's stress or frustration in the system, right?
Mm.
So all of the species, all of the time, if they would change their relationships with all of the other species in a way that reduced the competition, right? You don't want to compete more. You want an easy life, right? If I could use resources that nobody else used, that would make life easy for me.
This explains the life of cats really well. or I guess dogs too. You look at pets and you're like, man, you guys have really gotten yourself a good deal. Just sleeps on all the pillows in the house, asks for food 20 times a day. And I don't see her wanting to compete. She's like, this is my niche. I'm good. I don't need to compete.
Why would you? I think, like if you're a bacterium in a petri dish that's fed with King's medium, it's like, why would you evolve? Life is happy like this, right? It doesn't even matter if I evolve to be completely brain dead and I could never survive outside of this petri dish, but I'm being drip fed with the stuff that I need. So there's no need for me to do anything clever here, right? There's no frustration. There's no change in the system except degradation. So Daniel Power set up this model of the ecosystem so that the competition between species represented a resource allocation problem, right? That if you, in order for the system to do well at the resource allocation problem, the right species need to be in high density at the right time. That this one can't be in high density at the same time as that one, and these ones can, and these ones can't. And to make it interesting, he set it up that the rules of those interactions specified the rules of a Sudoku puzzle. So this species represents a 3 in the first cell, and this species represents a 2 in the first cell, and they're in competition because you have to pick, right? You can't have both numbers in high density at the same time. But the 3 is also in strong competition with all the other 3s on the same row, and all the other 3s on the same column, and all the other 3s in the same box. But it's less competitive with all the other species in the 3s in different rows, or the 6s in the same row. And when you run that system, at first, it's just, well, whoever happens to be in higher density first gets there first. They competitively exclude the other ones that they're in competition with. You arrive at some combination of species that represents what we would call a locally optimal solution to the Sudoku puzzle, which basically there's lots and lots of conflict going on. There's 2 3s in this box, and there's 2 6s in this row, and there's 2 7s in this column, and there's lots of conflict all over the place. But from there, they can't get any better, because there isn't any small incremental change that any of them can do that would enable the ecosystem to find a better equilibrium where there was less conflict. But if you allow them to evolve their relationships in the manner that I described, so only under individual level selection, they evolve in the direction that changes their relationships with others, that makes them grow faster. The relationships that they're most interested in changing are the ones which are in most competition, which are most frustrated. And that means that 2 species which are in high density at the same time change their relationship quickly, but 2 species that are in high density at different times change their relationship more slowly. And that differential easing of the frustrations is equivalent to the learning neural network. And over time, over multiple experiences, the ecosystem gets better at solving the Sudoku puzzle. And it was so good that he had to buy the book of the world's 10 most difficult Sudoku puzzles. And even then it solved 8 out of 10. So ecosystems are not supposed to be able to do problem solving, right? Because that would require the only system that's capable of solving any problems or optimizing anything is natural selection. So you'd have to have a population of ecosystems to do that. But this model shows that you don't need to have a population of ecosystems to do that. You've got adaptation at the system level that's created through the competitive adaptation of the components within.
Well, it's fascinating because it seems to actually say that the method of problem solving is directly opposite to natural selection, because what you see is not an increase towards conflict, it is a decrease of conflict. So it drives you away from natural selection to some degree, because if natural selection happens only in conflict, and what you see is that you have this problem, and what organisms do is they very naturally step away from conflict, and they're like, we'll solve this.
There's a looking up, looking down sort of way, right? If I look at what's happening, what's the nature of the relationship between one individual in a particular species and the other individuals in that particular species? Like, well, that's competitive, mate. If this guy has figured out a way to survive and reproduce better than this guy, then you get more of it. It's competitively excluding the other types within that species. That's true. That's natural selection. It's not wrong, but it's completely missing the point, right? That's not where the induction happens. It's not where the creativity happens. That's more like deduction. It's like if it survives and reproduces better, it survives and reproduces better. What more is there to say? But when you look at, which ones are going to survive and reproduce? What kind of adaptation causes it to survive and reproduce better than the other one, right? So the theory of natural selection doesn't have anything to say about that. All it says is, well, if there was something that enabled it to survive and reproduce better, then it would survive and reproduce better. That's an automatic consequence.
Do you call this natural induction, by the way? Is it natural induction? Is that the...
Yeah. So I would say, so the induction that goes on in your brain or in a machine learning system is designed or selected for the purpose of doing induction. But this is induction which happens naturally in a system which isn't designed or selected for the purpose of doing induction.
Why are people so obsessed with natural when it comes to defining their morality, do you think? Like if people are using natural selection to justify their individualism, they must believe that what is natural is best. But that makes almost no sense since we're sitting here talking from thousands of miles away on artificial equipment.
I believe they use kilometers.
I used an artificial coffee maker to make my breakfast this morning, and it just seems preposterous that we would think what is happening naturally in the background. I mean, I'm defining nature here as that which humans don't manipulate. What's so great about that? Nature seems like a mess. I mean, compared to what humans are capable of, we can choose to behave better than nature. Why are people so obsessed with justifying their behaviors based on what happens in nature?
So there's a way of viewing things referred to as the naturalistic fallacy, right? That because it's natural, it's good, and that doesn't follow, right? You can say, well, this is the way that nature is, but it would be better if it wasn't like that. Let's do it a different way, right? I don't know that I completely agree with you that the way that humans do things is amazingly brilliant, though.
Sometimes more than others.
Natural ecosystems had a level of maturity gained through their past experience, induced systemic intelligence through their past experience, the nature and the organization of the relationships that they had in those ecosystems. And what do? We just eat it. We just consume it. We just burn it. We dig it up and burn it, right? It's like, that's not a smart way. It's
good for the plants to burn stuff, they like all that carbon.
I mean, there are some interesting perspective on this because we live in the West, and in the West of the United States, we have terrible forest fires. And it's very hard for me to go into the woods and not think that it's our fault for having terrible forest fires because we don't have an active forest management approach where, we're not. On one hand, we are, extracting and burning and doing terrible things. But on the other hand, we're also not doing this thing of taking care of the ecosystem in a way that would nurture it and maintain it. And I think that that's the inductive leap here that humans could afford to make, which is that because we have defined ourselves through natural selection for so long, we have clawed our way to the top of some dominance hierarchy. And we have demonstrated that we absolutely are the most...
Or put there by a deity.
Or put there by a deity, but, in the modern era, I don't think that Dawkins thinks that we were put here by a deity,
No,
he
right? Certainly doesn't. No,
right? So
doesn't.
It's like, you don't even need the deity for this. You just have to have a belief in the supremacy of humans.
But it's a very competitive process that leads to those forest fire patterns, right? Because nobody wants to have the controlled burns on their county's wind zone, basically. From what I understand, when I was talking to a forest ranger recently, it was like, well, if we just burned this little part here at this time and this part at this time, we wouldn't have these terrible catastrophes that we're starting to have. But nobody can agree to do, even the most minor burn. Everybody downwind is like, absolutely not. And they all shut it down in committee. And so there is this intense competition between the interests of the whole and the interests of these individual, I'm going to call communities individuals. Yeah.
This is the perennial tragedy of the commons, isn't it? That for each individual, it makes sense to exploit the resources to your individual benefit in the short term, even if that will bring long-term destruction for everybody in the longer perspective.
But go ahead.
We know something about the conditions under which that can be moderated, right? When you have localized feedback loops rather than pooled resources, so that the consequences of selfish actions are differently visited upon the selfish individuals instead of just, you do a selfish action and then you run off and you do it somewhere else, right? You have to have those sort of localized feedback loops in order to stop the selfish individuals, right? But those localized interactions can be sort of just geographically local, but in more general circumstances, they can be a network of relationships that has the right kind of structural feedbacks, right? That yes, you're acting from your self-interest, but given the choices you have, given the social relationships you have, the choice that's best for you is actually this one. Oh, look at that. The relationships were organized in such a way that when you made the choice that was best for you, you did the thing that was best for the whole. Right? It aligns your selfish interests with the longer term collective interests.
And that's like that's the key to negotiating. It seems like even at a political level, it would be like convincing those downwind communities that, hey, this is going to work out for you better a year from now. Somehow.
Even though there's a momentary,
you need to change your relationship to these small burns, essentially.
Into the future as well,
into the
right?
Future, yeah.
Like, I think that this is about the storytelling that we do as individuals, as communities, as a species, if I can be so bold, which is that...
Be bold.
which is that we have a tendency to tell the story of nature red in tooth and claw, and that is what is successful. And the value of, now that it's possible to create these neural networks and look at how they interact and look at how they solve problems, it's possible to look at humans and model them as being a group that must solve problems, and then be able to show that what is effective at accomplishing those goals cannot be purely competitive in nature. We have to find a different story to tell ourselves. Otherwise, we won't be able to fix these things, because we'll get to some Pareto optimum where, you know, one country burns all the forests and another country has all the money and whatever.
Yes. Yeah, that the stories that we tell ourselves are important, right? To the extent that our worldviews influence our behavior, those views matter. And they are, when we find ourselves in a situation where our relationship with another person, be they near or far, or the relationship with the institution that we're a part of, that when we find that it's constraining us in some way, I don't want to do it like that. Well, the rules say you have to do it like that, or if you didn't do it like that, there'd be these consequences, that sort of mutual policing relationship going on or whatever. Or the cost-benefit analysis, given the options I have, says that I should do it like this. How do we view that? Do we view that as, well, it's the nature of loving connection that sometimes you have to do things you don't want to do? Or do we view it as, only an idiot would do that? Why don't you just cut that relationship? Just cut it and do what you want, right? So when you view the social network and the biological network of which you were a part as something which contains distributed knowledge about its past experience, I think that invites us to treat it with a little bit more reverence, that, cutting those connections is not, whilst it might give me short-term gain, cutting those connections makes the system dumber, right? It's cutting neural connections when you do that, when you break those relationships for your selfish interest. And it might hurt sometimes that you have to choose an action out of the options that you're given the constraints that are acting on you from the network of which you are a part. But that's what it means to accept that humbly, to accept that with love, rather than with a
emotionally unintelligent.
I'll try and keep it clean.
I mean, I immediately think of, we've been talking for a long time, and I could, wow, it's already been an hour and 40.
Yeah, maybe we should meet up again down the line, because I'd love to pick your brain just even about what the difference is between these different scales of organization. Like, we didn't even get into what an individual is versus a group, and it's not entirely clear.
And I have questions. There's a really interesting figure in the South Marie paper where you have this sort of you have this transition of something from kind of these nonsense pictures to something that actually carries meaning.
Mm-hmm.
But I think that there's not enough time.
Yeah, let's stop here for today. I think it's a really,
I've really enjoyed myself.
Really nice point. Thank you for
really
coming.
Wonderful.
It's been fun to talk to you, and I hope we can meet up again down the line.
I'd like that.
Excellent. Thank you so much.
Thank you. Bye,
Oh,
folks.
and where can people find you? Sorry, before we say bye.
Come back, folks.
Yeah, come back. Where can people find you
Yeah.
if they want to see more of your work? You have quite a. I think that you have the best scientist website that I've ever seen.
Oh,
I really
that's
do.
so nice of you to say.
RichardWatson.com. It's like very well laid out. It's very beautiful. It's got all your publications. You've grouped everything according to your field of interest and your studies. It's fantastic.
Well, the thing that was tricky, I spent a long time working on it and failing to begin even because I was struggling to, how do I talk about the things that really matter here? The loving connection that we have with one another and our opportunity to treat each other with respect, to treat each other as part of something greater than ourselves. How do I talk about stuff like that? And also talk about science, right? Because in the reductionist Western scientific view, you're not allowed to have an agenda, right? You're not allowed to
You're not allowed to speak
say,
openly
you're
of
not
your
allowed
agenda.
you're not allowed to say this is why I'm interested in it, or right, because it's difficult to present that, right, in a way that's that acknowledges the agenda that everybody has in the questions that they choose to ask and the ways in which they choose to investigate them. So I did my best to do that in that side. Thank you.
And so, do you use social media at all?
Yes, there's a couple of links to that on the website
Okay,
too.
excellent. All right, so RichardWatson.com, everybody. Thank you for joining us, Dr.
Thank you very
Watson.
much.
All right. Thanks, folks.
Thank you.
See you next week.
Thank you.